So here we're going to look at 4 examples where the function is written for us and our job is to find the vertex. So this focuses specifically on translation of parent functions. So you can see that I've put the function here and I've given you a little indication of what's occurring. This number is either going to move it left or right. And now remember that h is actually negative. So if we call this h, it's actually going to move it forward. Why? Because h's value in this case is actually 2, because when you plug it in, the negative is already there. So we have that 2 right there. Now k is either going to move it up or down. That's why I have this little indication. But k doesn't have any trickiness. K is just whatever you see is what you get. So at this point, it's just like the examples we just saw, where we're going to graph our parent function. Okay, so our parent function in this case is the absolute value. So I'm going to graph 0, 0, 1, 1, negative 1, 1, 2, 2, negative 2, 2. Now I'm going to graph this point, and this point will be at 2, negative 1, so 2, negative 1, and then from here I'm going to graph 1, 1, negative 1, 1, 2, 2, negative 2, 2, and that is my actual graph. And believe it or not, that's it. That's all you have to do to be able to translate a graph from a function that is given. Remember, this problem, this is the actual problem, and the explanation is could you graph that? So boom, we graphed it. And if someone asks you what happened, you could say, well, it moved right 2 and down 1. Okay, so even with the cube, same idea. The question is it going to move left or right? And remember, for h to be positive in here, it had to be negative originally, because I put the negative into the function that was already negative, making it a positive. So h is negative 3. In this case, I don't have a k, so does it move it up or down? It moves it nowhere, or 0. So we're going to graph our parent function. Please keep in mind that our parent function needs to be graphed on an axis that goes by 2's, because we're graphing a cube. Same thing with a cube root if you had one of those. So negative 1, the cube of negative 1 is 1. 1 cubed is 1. Negative 2 would be negative 8. 2 would be 8. Then I'm going to graph this instead. I'm going to translate that to 3, 0. So, sorry, negative 3, 0. So I'm going to go to negative 3, 0, put a dot, and I'm going to go 1, negative 1, 1, 1, negative 2, so it's in the middle now, down to negative 8. Don't forget to count and be careful. Here I'm going to go 2 in the middle and go up to 8, and I'm going to graph my cube. Cubes are curvy, so make sure you draw them curvy and they don't go in like I accidentally just drew. They go kind of out. I'm having a little bit of trouble, but I think I'll get it here. There we go. And then you draw another, like half of a parabola going that way to get that nice curvy in the middle. It is not flat, it is curvy. All right, let's take a look at the greatest integer function, which we haven't drawn yet. So what happens here? Nothing changes. You look inside, there is no h. It's not going to move left or right, so that's going to give you 0 for your h value. K is always whatever you're given, so k is 2. So what does the parent function of the greatest integer function look like? It looks, before you draw it, like a line. So the greatest integer of 0 is 0. Greatest integer of negative 1 is negative 1. 1 would be 1. The greatest integer of negative 2 is negative 2. 2 would be 2. Remember, you're rounding down. So if I round a whole number down to a whole number, or its greatest integer, then it would be itself. Okay, and so then we would draw little barbells, but we don't want to, we don't have to do it right here. This is just to give us an idea. We're actually going to draw those little barbell looking shapes at its new vertex, which is 0, 2. So at 0, 2, we graph here, and then again, from here, 1, 1, negative 1, 1, 2, 2, negative 2, 2, and then I'm going to draw barbells from here. Now, one thing that'll happen is once you draw these, is a lot of students will just leave this graph. And that is like leaving a absolute value or a square graph without arrows on it. You do, believe it or not, need to go back and finish this graph. I mean, there's no graph here or there. So a lot of teachers, including myself, want you to go back and actually fill in the rest of the graph that wasn't provided by the parent function. And that's an important thing to do, because some teachers will, take off 1 point. It's like leaving arrows off, and it's important to note this graph does have, it does go on in infinity. All right, so the next one is the cube root, one we haven't done yet either. So for the cube root, nothing's going to change, and that's what's nice about it. And if you start to realize early on how this works, it's just a consistent way to do all the problems, and that's what the point of the chapter is. So here, remember, h, in order to be negative, h would actually be positive because you're going to put 1 into the formula that already has a negative, and so h is actually 1. K never changes, so it will be 2. So we're going to graph our parent function. Our parent function for the cube root is 0, 0, negative 1, negative 1, 1, 1, and be careful with this next one. Instead of being negative 2, 8, it's actually negative 8, negative 2, because it's the inverse. It is the reverse. So 2, 4, 6, 8, 2. And then that would be our parent function, but we're going to graph this one at its new vertex of 1, 2. So 1, 2 would be there. And then from here, we would go 1, 1. Negative 1, 1, and here we'd go 8, 2, which would be right here in the middle, and then I'm going to have to count this one, 2, 4, 6, 8, negative 1. So from here, 2, 4, 6, 8, negative 2, right there. Just be careful with counting that, and just take your time and slow down, make sure you have it right, and take your time drawing the shape. Okay, so it not that complicated and very consistent. And again, if you wanted to describe what was happening, this graph was moved up 2, this graph was moved right 1 and up 2. And that will be part of our next examples to actually describe that.